All right, so let's look at this problem. It's a truss problem. As you can see from what was asked, I went ahead and made some little marks on the 4 bar forces that were identified in the problem. So those are the only 4 that I need. So you can approach this problem a number of different ways. You can find the reactions and do method of joints and work your way through. But I think a more straightforward and efficient approach would be to try to cut this structure here and do method of sections, which is what we just talked about. Also, this guy we can probably find pretty quickly. Yeah, if you look at, first of all, if you just look at each of the 4 forces and look at the ends of each element, and you look at force CG, you'll notice at this end, well, that doesn't match any of our cases that we talked about, but C does match case 2, right? So based on our case 2 that we had, we should be able to say that the force in CG is 0, and I'll even mark that as a 0 force member. So that's my logic. Now, the danger to this is, what if it's really not 0? What if you messed up? You could always come back here. If you're not sure, you can do a method of joints at C, and you would find that CG is 0. But you don't have to write it down. I'll accept that you identified it as 0 force member. Of course, again, with the caveat that it needs to be correct. You can't just say, oh, this is a 0 force member by case 1. No, it's not. Okay? So we do have one of them done. So now if we're going to cut this structure here, which side do you guys want to work? The left side or the right side?
I want the left side.
It's hard to see, but this is a pin connection, and this is a roller. So I would lean to the left side just because I only have to find one reaction at the supports. And I only have to keep track of 2 forces, external forces. The right-hand side, I have to keep track of 3 and 2 reactions. So just a little bit more. Is it wrong to work the right side? No. Remember, both sides have to be in equilibrium, so it would work either way. But I think today, for demonstration, I'm going to work the left-hand side. So I'll just mark that I'm going to go this way. So with that said, then I want to find the reaction at A. So I'll go ahead and cheat a little bit and use the actual problem statement as my free body. And also show you that I would assume EY and EX in this direction, but I don't really care about them because I don't really need them to solve the problem. So I'm going to sum moments about E using the whole free body to find AY. So let's do that. So right-hand rule is my sign convention for moments. So I'm going to sum moments about E and set them equal to 0. So let's take care of all the applied forces first. So this half kip load passes through E. I don't need to keep track of it. Then I have 1, 2, 3 1 kip loads. What kind of moment did they create around E? Positive or negative? Positive. So I'm going to write 1 kip, and then I'm going to add up all the forces. So the first one has a moment arm of 12 feet. The second one has a moment arm of 24. And the third one has a moment arm of 36. So that accounts for the moment about E for those first 3 forces. Then I had this half kip, which is also positive. Positive. And it has a moment arm of 48. So there's all my forces. And then I have my unknown AY, which creates what kind of moment about E? Positive or negative? Negative. So that would be AY, and it also has a moment arm of 48 feet. I think the answer is 2. But please check. Anybody get 2?
Yep.
Anybody else? Not that I don't trust you, Mr. Long. Anybody else give me a thumbs up?
I got 1.5.
Oh, you got 1.5s? I have a feeling that's incorrect.
36 plus 24 plus 72.
Where's the head?
Half here.
Okay, Ron, I got you.
I'm pretty confident it's 2 kips. Now, how did I know that without calculating it? Well, look at these forces. They're kind of symmetric. You would expect half the total force to go to one side and half the total force to go to the other side. So I just added up all my forces. It came to 4. Half of 4 is 2. I'm hoping this equation gives us 2 also. I think it does. Okay. So now, let's draw the free body diagram on the left-hand side. So I'll come over here, and I will attempt to draw a free body diagram. And then on that, I will put my reaction that I know, which we just found, which was 2 kips. I'm going to do these in blue so we don't lose track of them. This was half a kip, 500 pounds. This is 1 kip. I think that's it. And then I assumed a tension force in GH, a tension force in BG, and a tension force in BC. And I'll just write these numbers in here. It's 12 feet of each bay, and the height is 15. 16. Thank you. That works out nicer. So the actual slope, if you divide everything by 4, it's a 4.3. So that's pretty handy for calculation. The author likes those 3, 4, 5 triangles quite a bit. Any questions about that? So method of sections. Where should we sum moments? Where is a point where at least 2 of my unknown forces are concurrent? B. Now B is the obvious one because you can see they both go through B. Where's another point? G. So just so you can see it, this won't be to scale, but there is a point out here somewhere, G, that I can use. And then what else? Just like the example in class, BG is the only one that has a Y component, so I can some forces in the Y. I can apply those 3 equations any way I want because they don't depend on each other. So I can sum forces in the Y first, I can sum moments about G, then I can sum moments about B. The order is not important because they're independent equations. Okay? I'll do a moment one first. I'll sum moments about B. Set equal to 0. So about B, here's point B. BC and BG pass through B, so they create no moment. But I do get a moment from GH. What kind of moment is it with my sign convention? Positive. So I have force in GH, and what's the moment arm? The height of the structure? 16 feet. This 1 kip force here, what kind of moment does it create about B? No moment.
Oh, wait, no.
The line of action goes right through B. Now these 2 both create moment about B. They both have a 12-foot moment arm. You can do them individual or you can do the sum, whichever one you like. I'll do them individually first so you won't get confused. We'll take the half kip force first. What kind of moment does it create about B? Positive. So I'll have 1/2 kip times 12 feet. And then the 2 kip force, negative moment. Now I'll just kind of write in that you can see the equivalent would be the sum of these two, which would be 1.5 kips up, right? And that would create what kind of moment? Negative. So it's the same as that. You'll get exactly the same result. Whichever way you see it best. They're identical. So I can now solve for HG, or GH, I called it. What is that? It looks like it's going to be a positive value. I don't know what it's going to be.
11.5.
Say again?
1.125.
1.125. That sounds reasonable. Anybody else get that? Bless you. Confirmed? All right. And it came out to be positive. Does it make sense that GH is in tension? I think so. Look at all the loads. They're all down. They're all gravity-based. You'd expect all the bottom chord elements to be in tension and the upper chord to be in compression. And speaking of that, how do we get that upper chord element? The one at BC. How can I get that? One equation, one unknown. We get some moments at G. So let's do that. So again, right-hand rule. Going to sum my moments at G. Make sure it's in equilibrium. So about G, notice that GH and BG both have no moment. But BC does. What kind of moment does BC create about G? Positive or negative? Negative. So I'm going to have negative BC. And its moment arm from G? It's the height of the structure, or 16 feet. So what else do I have to include? Well, I've got 1, 2, 3. I got all three of those forces to deal with. So I'll start with the 1 kip. Does it create positive or negative moment about G? Positive. So I got 1 kip force, and its moment arm is 12 feet. And I got this guy. Are we going to do it as 2 forces or as its equivalent force? We'll do the equivalent. So it's really 1.5 kips up. What kind of moment does that create about G? Negative. So I have minus 1.5 kips with a moment arm of 24. So what should BC be? Oh, I wrote it backwards, but that's okay. It looks like it's going to be negative. What's the value?
1.5.
I don't know. Anybody else get 1.5? I see 2 heads. I need 3. 3. I feel like I'm auctioning something. Going once. Going twice. Sold for negative 1.5 kips. So now what? What's left over? What's the final one? BG. As we talked earlier, BG is the only force with a Y component, so we can just sum forces in the Y direction. So let's do that. So the force in BG is going to be 4/5 of the force, and it's acting down. So 4/5 of BG, and I've got 1 kip acting down. What else do I have? This equivalent is 1.5 up. So what is the force in BG? It looks like it's going to be positive. What'd you get?
0.4.
0.4? I don't like that. I don't know why. I can't tell you why. Anybody else get that?
0.65.
I like that one better. So any questions about that? So since I assume tension for everything, then I've got tension, compression, tension. Any questions? Final comment, that was pretty straightforward. That was pretty much identical to the one we just worked. So just kind of reinforce that.
How would you check CG?
How would I check what?
CG.
CG.
The zero.
If you wanted to do that, what if I took a equal free body diagram of joint C? So I've got force in CG, a force in CD, and a force in BC. Okay? Now remember, the goal here is because I ask for CG, this is the only one I want, right? So, how can I get that with one equation and one unknown? Some forces in the y direction. So I'll assume up is positive. I'll sum forces in the y direction, make sure it's in equilibrium, and all I get is minus CG. So CG has to be 0. And that's what the zero force member cases give you. It gives you this. You know by inspection you have a situation that looks like this. 3 members connected, 2 collinear, no external load. Case 2, by default this has to be 0. Well, not by default. By equilibrium it has to be 0. All right, any other questions or comments? All right.
Some of those forces are supposed to be equal to 0, right?
Sum of what forces?
The MB, the multiple, FGH, LCB, and SBG.
If I sum forces in the x direction, you have to get the x component of BG,
Okay.
which is 3/5. So 3/5 of that plus this plus that ought to be 0. It looks like this should probably be 3.75. 3/5 of this is probably 3.75. I'm hoping. And then it would work.
Okay.
Should you try that? All right.